Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is directed acyclic graph. In short, we will call this as DAG. This topic you'll find in 4th unit as topic number 3. Now let's get started. A directed acyclic graph is a graph that is directed and contains no cycle. That means it is a digraph. DAG is a digraph, but we cannot form any cycle with the vertices, with the available vertices. Now let's see some example. Assume that I have 3 vertices, U, V and Z. All these 3 vertices are connected. It is strongly connected and the directions are something like this. That is U to V, you have a direction. V to Z, you have a direction. Z to U, direction. So this digraph is forming a cycle. So this is called as what? Cyclic graph. Now what do you mean by acyclic graph? Acyclic graph or directed acyclic graph is a graph that is directed and contains no cycle. That means you can have an edge from U to V and from V to Z, and there is no edge from Z to U. Okay, only the edge from U to Z. So it doesn't form a cycle, right? So this is what acyclic graph and this is what cycle graph. Now we'll take some example. So you can draw a graph in 2 ways. The directed graph I'm talking. A digraph can be drawn in 2 ways. Cycle graph and acyclic. A cyclic graph and cyclic graph. Now what do you mean by cycle graph? Both are directed graphs. If it is a cycle, if it is a cycle, both are directed graphs. Both are digraphs, but cycle graph will be having a cycle. Cycle means there should be a direction from one vertices to it has to go to all other vertices and it should come back to the same vertices. Then it is what? A cycle. It forms a cycle, right? So it is a cyclic graph. Now look at this acyclic graph. We started with A to B, B to E, and you cannot come from E. So it doesn't form a cycle. Again A to C, C to D. It is an acyclic graph. So basically we do have some properties of this DAG. The basic properties of this directed acyclic graph are 2 properties. The one is directed edges and the second is acyclic. Without this you cannot say such graphs are directed acyclic graphic. So directed edges are what? Each edge has a direction going from one vertex to other vertex. That is what directed edges. Acyclic in the sense what? No cycles exist in the graph. These are what? 2 properties. When these 2 properties are satisfied, then the graph G is said to be DAG. Right? Now, so majorly what is the applications of this directed acyclic graph? So applications of DAG include the following. The first application is what? Inheritance between C++ classes or Java interfaces. And the second is prerequisite is between courses of a degree program, scheduling constraints between the task of a project. So these kind of applications will use a cyclic graph because we'll have a direction but we don't have any cycle. And we do have the other applications what we will have as per the syllabus. The first is what? Topological ordering. That will make the other video to discuss what is this topological ordering, and shortest path, finding the shortest path. So these are what applications. We'll use DAG or digraph with no cycle in this topological ordering and shortest path. Right. Thank you all.